welcome you all to Java Masterclass. So I'll introduce to you all Stueli Technology first. So Stueli Technology Private Limited has a successful track record in the field of academia, research, training, recruitment, and job assistance since its inception in 2018. We also offer training and internship for all levels of the professional world. It starts from plus two level to a seasoned professional. We in Struwelli Technology embraced academic and research development as no civilization can survive without education and can't progress without research. We work with each applicant to prepare them for employment ready. Struwelli Technology bridges the gap between employer and employee via product or industry specific selections and pre-employment training. Just for a quick look, I am sharing my screen and showing all the unique services which Struwelli Technology Private Limited family holds. So I'll be sharing my screen now. I hope my screen is visible to you all. Okay, so for learning and teaching platform, we have Prayug. For hands-on internship programs, we have StuIntern. For crafting professional AI resume, we have Resumotion. For personalized career guidance and job search support, we have Navrojan. For diverse study material and interactive courses, we have Vidyapun. For personal and professional growth through psychometric analysis, we have Sudakshta. For research, we have Anushram. So these are all the unique services we offer at Struwelli Technology. So your today's trainer is Aditi. So she has over 4+ years of experience as technical trainer. Currently, she is working as an online core and advanced Java trainer with Institute Squad Infotech Private Limited. So over to you, ma'am.
Thank you, ma'am. Hello, everyone. Good afternoon. So today I'm going to present you few things related to Java. The main topic from the Java, that is OOPS pillars. We say it as object-oriented pillars. So in our Java masterclass, we are going to learn object-oriented pillars in Java. Okay. So shall we start? Everyone? Everyone is ready?
Please respond and try switching on your webcams if possible so that we can make this session more interactive.
Yes. Okay. Okay then. So how many of you are from technical background? Can you tell me how many of you are from technical background or you have knowledge of any programming language? Okay, Satyam, Shantanu. Okay, fine. There are many students from the technical background. That's good. So as you know, as you are from the technical background, I just want to know that, can you tell me why we need any programming language? What is the need of programming language? Anyone? Can anyone tell me what is the need of programming language? Why we need any programming language? Okay, Tawhid. Any other? Okay, fine. Correct, Yashasvi. Yes, Swati. Correct. So, can you first tell me which is your preferred language? English is fine, or should I continue with Hindi? आपका प्रेफर्ड लैंग्वेज बताओ, हिंदी में ठीक है या इंग्लिश में ठीक है? Okay, so most of the students are saying English, so we will continue in English itself. So yes, as Yashasvi and Swati told about the main purpose of any computer programming language. Suppose you went in another district of India or another country out of India. So there is a major difference between his language. The major thing when we try to communicate with other people, there is the barrier is language. Why? Suppose you are going to any Spain country or any South Indian states also, you can say. So there is major differences language, because the South Indian people, whatever that they speak, if we know that language, then that is good. If we don't know that language, then we have a communication gap, because the thing that when we try to communicate with them, they will not be able to understand, and whenever they want to communicate with us, we will not be able to understand, right? So there is a communication gap between us, and that is the main barrier is language. So we need to go through one person, or you can say one translator, which will be your communicator, right? So which will be your communicator, which will translate whatever you are saying into their understandable language. That is the main thing. So here, whenever we are using any computer programming language, that is an intermediator, or you can say it is a translator, because computer doesn't understand human readable language. We understand only human readable languages, and computer understand machine language, which is into 0 and 1 format, right? Because it is always into 0 and 1 format. So as I said, the computer programming language always used to interact with the computers, which is in the human readable format. So whatever we want to develop, whatever the software we want to develop, whatever the instruction we want to give to the computer, it will get converted by the computer programming language, and the computer will understand that language or that instruction, and that will get executed. Then whatever the output computer is going to give you, again, that is not into the human readable format, that is into 0-1 format, right? Which is a machine format. So again, the computer programming language is going to convert it into human readable format, and then it will show it to you, right? So that is the main purpose of any computer programming language. Clear, everyone? Any doubt here? Okay. So we will first understand that why we need any programming language, or why we need Java, why the Java is invented. So before Java, if you say that there are multiple languages such as Fortran, COBOL, Pascal, etc. And main was assembly language. So what is the purpose of assembly language? Assembly language was used to produce highly efficient programs. Okay, it was used to produce highly efficient programs, but it is not easy to learn. Whenever we are saying assembly language, it is directly going to perform the operations or instructions we are going to give directly on the RAM, ROM, okay, or the registers. Okay, so whatever the motherboard is there in our computer, we are giving instruction directly to the motherboard to perform some, to allocate some memory, to perform some instructions, or perform some operation like addition, subtraction, etc. Okay, so the assembly language is not very easy to use. As many of you are from computer background, you may know the assembly languages, whatever the assembly languages. As well as in assembly language, there is a main problem was debugging. Debugging means whenever we want to try to find out if our program is not working, where it is going wrong, what is the bug, we need to debug that program to find out where the problem is occurring, right? That process is known as debugging. And the debugging in the assembly code is it's quite difficult. We will not be able to find out very easily. That is the main drawback of assembly language. Then there were Fortran language. Fortran were not that much good for system code. System code means operating systems and any other applications which we are using as a system basis. Okay, that means which are internally system used, OS operations, you can say. Okay, so that is for system code, efficient programs for scientific applications. So Fortran is not that much useful for these types of applications. Then there is a basic language. Basic is also one computer programming language. Basic was easy to learn. It is not that much very helpful, or you can say it is not powerful. It lacks of structure, so it doesn't have any proper structure for perform any program. Okay, and it is also not good for large programs. If your program is very large, then we are not able to use the basic language for performing that. So basic, COBOL, and Fortran, these are languages. These were not designed around structured principles. So they doesn't have any structure which you will be using, and you can perform the program, or you can put your program or code into that structure and execute it. So it was not the thing. Okay, these are unstructured languages. Pascal language was structured language, but there is an efficiency issue. The program which we are developing into the Pascal, which is not efficient, which is not that much good. Okay, that's why these are the different programming languages we were using before the Java. As well as there is a need of structured high-level programming language which will replace our assembly code when creating system programs. This was the need. Okay, so for this need, the first language, computer programming language, or the modern age language was created, that is C language. Okay, so the first C language is created, first the C language is invented, and then multiple languages are invented based on these types. Okay, so C language considered by many to have marked beginning of the modern age. Why? Because the drawbacks from the unstructured languages, we are overcoming it with the structured language, that is a C language, which is a high level language, and it is also efficient, and it is also easy to learn also. Okay, so this is the beginning of modern age of computer programming languages. But there are also some drawbacks of C language. What is the drawback? So if we can create application, or we can create a project into the C which reaches a certain size. Okay, if its complexity is increasing or exceeding, then we will not be able to use C, which will not behave like a normal application program. So it gives some problems when it reaches to certain size, if its complexity exceeds. That's why to solve this problem of C, the new way of programming was invented. These are new programming techniques. Okay, this is not a computer language. These are only programming techniques. The programming techniques are called as object-oriented programming techniques. Okay, or object-oriented programming principles. So these are introduced to overcome the problems of C language, which are, it should use some, if our project is reaching to a certain size, or if its complexity exceeding, then whatever the problems we are getting, those problems were resolved by the programming principles. Okay, object-oriented programming principles. So these programming principles, or these programming methodologies, helps organize complex programs through the use of 4 pillars basically in Java, but here I have mentioned only 3 because these are going to add into C++. Okay, so inheritance, encapsulation, and polymorphism. These 3 principles of object-oriented programming are added into into the C++ language. So it is nothing but the enhancement to C. So it is a C language itself, but with the object-oriented programming principles are added into those C structure. Okay, so the C++ language was invented with this programming methodologies. Then the C and C++ were working fine up till one point occurs, that one drawback of the C and C++ language programs or applications were that these are designed to be compiled for a specific target. Designed to be compiled for specific target means if we are performing any application or developing any application on a Windows system, it will only compile and gets executed on another Windows system. So if you want to develop an application, or if you want to execute the same application on Linux system, Unix system, or any other Mac system, then it will be never going to perform that, or it will be not going to execute on those other platforms. If you have to do that, then you have to develop a new software or new application for that specific target, or that specific for target, you can say, for that specific operating system. Okay, so that's why the main drawback of C and C++ languages are, these are platform dependent languages, and it leads to the one language which should be platform independent. That means if we are developing any application on any system, it will be anything. You can say it will be on Windows, it will be on Mac, Linux, Unix, any system. It can be executed on any other platforms also. That is the main pillar or main purpose of inventing Java. Okay, so the need of platform independent language that could be used to create softwares, which is to be embedded in various consumer electronic devices also, such as microwave ovens, remote controls, and this lead to the creation of Java. Okay, this is also known as architecture neutral, because it doesn't have any concerns related to architecture. Okay, that means basically system. We can, whatever the application you are developing, it develops on the concepts of VORA, write once, run anywhere. Okay, so whenever you are developing any application using Java, it can be executed on any other platform. You have to just write it once and you can run that application anywhere. Okay, so Java was conceived by James Gosling, Patrick Norton, Chris Worth, and Ed Farr, Mike Sheridan at Sun Microsystems Inc. in 1991. Initially, it was called as GreenTalk. The file extension for this was .gt. Then later it was named as Oak. And after that, it was renamed Java in 1995 because it was already the trademark of Oak Technologies. Okay, so that is the main reason we are using currently the name Java itself for referring to this programming language. Okay, now we will coming back to your types of applications, what types of applications you can develop using Java. These types of applications means these will provide you different, you can say, path to your careers also. Okay, so for example, if you want to develop any softwares that has desktop GUI applications, or you can say that is a standalone application, which will be executed on the desktop machine or Windows-based machines or any other machines also. But those are standalone, मतलब single machine पे ही execute होगा. Okay, so we Java provides you some technologies like AWT, Java, FX, Swing, which are used for developing such type of standalone applications. Second one is applications for mobiles. So Java ME and Java Android also we are using for developing mobile applications. So if you learn this Java language, you can open the path for Android also, that is application for mobiles you can develop, as well as you're opening your path for Android developer. Then the embedded systems. So there are embedded systems in our system also. So for embedded systems also, you can use the Java language for developing the applications or systems directly. Web applications, widely used nowadays because everything is on internet. So web applications are nothing but which runs on server side and creates dynamic pages is called web application. Okay, so currently we are using lots of web applications because everything is on internet, right? So Java provides you some technologies like servlets, JSP, JSF, etc. These technologies are used for developing or creating the applications in Java. Examples are IRCTC, which is Railways, Indian Railways website, Java T-Point, IBM, Google Maps. These are all currently known as the web applications, or you can say these are developed in Java. So if you are using your Java as a career, then you can go for the web applications. So if you are learning the or developing the web applications, you can become web developer or web designer also, because in a web applications, we are going to design front-end technologies also. We are going to develop web pages also. So if you learn this, you will be able to go for the career path like a web developer and web designer both. Then application servers, the servers which are developed in your while you are executing any application. So these servers are also developed in Java. For example, Tomcat is one server, Glassfish is server. So these are application server where we are executing basically. We are deploying our code and executing our application, web application basically on our application server. So if you learn Java, you can directly work for this application servers. You can develop application servers as well as you can go for server management part also. Web servers, the web servers, you can develop the web servers which are executed directly on the web. Okay. Application for enterprises. Application for enterprises are also known as enterprise applications. Java provides you the technology EJB for developing or creating enterprise applications. So these applications are distributed in nature, such as banking applications. So, for example, any banking application, consider SBI. They are managing their data centrally. You can go to any branch and access your account. So this is possible only because of enterprise application, because it is a centralized, distributed in nature, okay, over internet. So this is the enterprise application. So if you are learning Java, then you can go for the path like this banking applications. You can work for the banking software development also. Okay, so this is also one career path. Then scientific applications also you can develop using Java. Scientific applications are nothing but any, you can take any, like ISRO is using some programming, right? So that is also one scientific application. So you can use that Java language for coding purpose to give instructions to any applications, which is scientific application. Next one is, which is nowadays widely used, is big data technologies. Big data technologies, you must have heard about Hadoop, right? So big data technologies are also, if you know or if you have the knowledge of Java, then you can go for the big data technologies. It is also opening one career path for you. You can learn Hadoop and then you can go for the big data big data technologies also. Okay. Then the business applications. So business applications are nothing but any business related application. You can develop any business related application, retail, or you can say real estate business. You can develop any business related applications. Okay. So these are different types of applications. That means these are opening a different career paths for you. You can choose anything when you learn this particular course, or when you learn Java, you are going to opening multiple paths for you. So that's why nowadays Java is widely used, and there is multiple hiring is also there for Java programmers. Okay. So because of it is widely used for developing multiple applications. And main thing, Java provides you a structure. It is a structured language, high level language, as well as it provides you security. Security means the code which you are using, it has some with using the exception handling concepts or security concepts, you are going to secure your code, secure your applications. That's why these are widely used for banking applications. Okay, so these are nothing but the different career paths for your, if you learn Java, then these are different career paths for you. Now coming to our main principles, as we have seen the introductory part of all these. In C++, only inheritance, encapsulation, and polymorphism was added. But in Java, there are 4 pillars of OOPS, or you can say object-oriented programming principles. There are 4 principles. First one is abstraction, encapsulation, inheritance, and polymorphism. One by one, we are going to see in detail. So first, we are going to see what is abstraction. Abstraction is nothing but we are hiding the unnecessary details and showing only important part. Very basic example of the abstraction is nothing but the ATM machine or coffee vending machine. Okay, so where we don't know internally how the ATM works. We just put our PIN code, we just put our ATM code and then it will give you the balance inquiry. We can withdraw the amount, you can deposit the amount, everything we can perform using this machine, right? We don't know how internally it is working. So what it is exactly doing, it is hiding everything, internal working of ATM, and it is only showing you the part which is important for the user. What is that? only these buttons. A card machine insert करने के लिए आपको एक slot दिया जाता है, and one screen. That's the only thing it is giving you, right? So these things we can perform in a similar manner in Java also. Okay, so abstraction basically in coffee vending machine, if there is a coffee machine, we are putting all the ingredients, coffee, then sugar and milk powder, everything, water, everything we are putting into it, right? So we don't know how it is internally mixing all these ingredients and giving you the coffee, right? So it is also hiding you from you the internal working of copy machine. It is only showing you the important part, or it is only releasing the copy for you. Okay, so everything we are hiding certain details and show only essential information. This is the concept of abstraction. We can achieve abstraction in Java using two ways. First one is abstract classes, which is also known as partial abstraction, because abstract classes contains abstract methods and non-abstract methods. That's why abstract classes are partial abstraction. Second one is interfaces. Interfaces is also known as full abstraction, because interfaces we can write only abstract methods, and later now after Java 8 version we can add some non-abstract methods also into the interfaces. So we can achieve abstraction in Java using two concepts, abstract classes and interfaces. Okay. Second main pillar of the OOPS is encapsulation. Encapsulation is nothing but a mechanism of wrapping data and code together. You can say variables and methods together as a single unit. Simple basic example is a class. If we are writing any class, then we are writing the variables into it and methods into it. So we are combining it into or wrapping that everything into a one class, right? So the main, we are encapsulating these variables and methods as a single unit, as a class. Okay, so main example of this encapsulation is class. The variables of the class will be hidden from the other classes and can be accessed only through the methods of their current class. So how to do that we will see. So main difference between abstraction and encapsulation is that abstraction hides functionality. So we don't know the functions of ATM machine, right? But encapsulation hides the data. So suppose you are developing any application for login. So in login, we never show password because password is confidential, right? So the password should be accessible only within the same class, within the same method. So how can we do that? For that purpose, we use this encapsulation concept. Basic example for the encapsulation is a capsule, normal medicine capsule, right? So if you are using this medicine capsule, then multiple medicines are combined or encapsulated into this capsule, right? So in the same way, in Java, we can achieve the encapsulation by creating a class, by writing the variables and methods into that class. We are encapsulating methods and variables into a one single entity or single unit, that is class. So encapsulation in programming, we can achieve by creating a class with some variables and some methods. Okay. These, if we don't want to make these variables should be accessible outside of this same class, we have to make these variables as private. And to access these variables, we create methods of the class. Okay. So we achieve the encapsulation in Java using access modifiers, that is private data members, and public methods to access these private members, known as getter and setter methods or mutator methods. Okay, accessor and mutator methods. Clear till here? Anyone has any doubt? I think there is some network issue from your side. Please check your network issue. Okay, fine. So main difference between abstraction and encapsulation, as I told you, that it hides the functionality and encapsulation hides the data. So first one is abstraction solves the problem in the design level. So it is abstraction we are achieving at the designing level. It is not achieved at the implementation level. We are not changing anything. We are only changing the designing of your application by using abstract classes and interfaces. But encapsulation solves the problem in the implementation level. How? Because we are, for encapsulation, we are using access modifiers and the methods to access these private members. Okay. So abstraction is used for hiding the unwanted data and giving relevant data. Encapsulation means the code and data into a single unit to protect data from outside world. Abstraction lets you focus on what the object does instead how it does it. Okay, instead of how it does it. Encapsulation means hiding the internal details and mechanics of how the object does something. How the object is doing something that we are hiding from our using the encapsulation concept. So abstraction is outer layout used in terms of design. Okay, for example, outer look of a mobile phone, like it has a display screen, keypad buttons to dial a number, but we don't know internally what software is dialing a number, how it is working, right? So mobile phone is also the one abstraction example. In encapsulation, it is an inner layout used in terms of implementation. For example, inner implementation detail of a mobile phone, how keypad button and display screens are connected to each other using circuits. That is the implementation details, okay, or inner layout, how they are performing these things. What should be visible on your mobile, that is dependent on the encapsulation concept. Okay, so till we have clear two pillars of the OOPS. First one is abstraction and second one is encapsulation. Now going forward with the third pillars of the OOPS, inheritance. Generally, we inherit everything from our parent, right? So parent, grandparent, everything. We say that we are inheriting some qualities, some properties, or like hair color, eye color, right? So these things we are inheriting from our parents or grandparents, as well as we inherit properties also, like one bungalow or apartment, car, etc. Okay, so just for example, we are inheriting all these, we are acquiring some properties of from our parent, grandparents. So same thing here in Java also, we can create one mechanism. It is just a one mechanism where one class can acquire the properties of another class. Okay, so we can inherit the properties, members of one class into another one using inheritance concept. So basic example, as I told you, we are inheriting the properties or some features from our parents, grandparents. Okay, so inheriting into a child, parents property into a child. Another example is this is a practical example. You can say programmatically, one animal is class is there. So we have generalized it, that is animals, all animals. But if you want to differentiate it between, or we want to create some different properties for the dog and properties for the cat or any other lion, tiger, etc. So we can simply create different classes which are used for different entities, so that these are going to you can say point to a particular animal. But whatever the generalized thing is, like color of a animal, name of a animal, if you are giving any name to that, so you can give that things, whatever the common things are there, we can write into the animal class. So in Java, we can achieve the inheritance. There are multiple types of inheritances in Java. So basically, we are creating a class where the common properties will be saved and only the differentiated properties will be added into the child classes. Okay, so that we don't have to write the same data into different classes. Okay, the main purpose is we are using a single class for storing all the common properties, so that these data, whatever the data you are writing into this animal class, this should not get repeated and it should not waste the memory. Okay, so this is also one design level implementation. Here, when you are developing inheritance or using inheritance in your application, you are basically changing your designing purpose. So whatever the common properties for dog and cat, we are storing into animal class, and the specific properties for dog, we are saving into the dog class. Whatever the specific property for the cat, we are saving into cat. So the repetitive data, the repetitive code is going to be in. That means it should not waste our memory. So the main purpose in inheritance, it should be reused, or it should the common data should not be repetitively saved. And because if we are saving it repetitively, that means we need memory space also, right? So it is, if we are saving it multiple times, the memory will get wasted and your programming will also lag. Your program also executes very slowly. That's why the inheritance is also we are performing at the designing level. And the last point from your object-oriented programming principle is polymorphism. Okay, so it is the concept. Poly means many. Okay, so it is the concept by which we can perform a single action in different ways. So basically, we can give multiple thing to this but one thing. Okay, or multiple forms to one thing, anything. For example, in day-to-day life example, if I will give you the water, if it is in the liquid form, if we freeze it, then it will become solid, that is ice cube, right? If we evaporate it, it will convert it into gas at a some boiling point, right? So the water is same, but if we are making it into, or we can use it into different forms. Okay, so that is the main thing. The water is one thing which can be used in multiple ways, or you can use in multiple ways also. So you can use the same liquid water in another form as ice cubes, gases. We never use this, but if we evaporate the same, it will become a gaseous state. Okay, so this is nothing but one example of the polymorphism, one thing with multiple forms. Same, if we give one more example for this, is human behavior. It changes person to person, right? So human is same, but the behavior of the person or that human changes with whom he is or that person is talking. So the human behavior is also one of the example of polymorphism, or that human is working as employee, it is working as student, everything, then that is also one thing. So the multiple forms are there. And the computer on off switch also one example. You can use that switch for starting your computer and also for shutting down your computer. Okay, so it is, the button is same, but it performs two operations, switching on and switching off. Same. Okay, so these are few examples of polymorphism, which are real-time examples, you can say. And we can achieve polymorphism in Java using two concepts, that is overloading concepts and overriding concepts. In overloading, we perform two operations. First one is the constructor overloading. Second one is the method overloading. So in overloading, basically, we are writing one method. I am giving the example of method overloading. We can write one method with different types of parameters, number of parameters. You can give the same name to a method, but only the difference will be number of parameters or types of parameters. So you can overload that method. You can write n number of overloaded methods in your code. And this is possible within a single class. Okay. Overriding is, as we have seen, the inheritance concept. So overriding is always performed in the inheritance concept because we are using the same method name or signature from your parent class into a child class. Only the difference here will be the implementation. So whatever the implementation you are writing into the parent one, you can change that implementation into the child. Okay, so these are the two, and overriding is only possible in methods because constructors are never get overridden. Only constructors overloading is possible. Okay, so we can achieve the two types of polymorphism basically. The constructor overloading is compile time polymorphism, and this overriding is runtime polymorphism. Okay, because it will be achieved at the runtime, and at the compilation time it will get resolved the overloading concepts. Okay. Fine. Understood all these points? Any doubt? Anyone?
No, ma'am. Understood.
Okay. Okay, so if you have any questions, you can ask. Anyone has any questions? Okay, fine. Others also, can you please respond? Any questions from your side?
Hello everyone, hello students. So how was the masterclass? Please drop your feedback in the Zoom chat box.
Yes, please share the feedback.
Yes. So that we can conduct another masterclass for you guys.